What is up, everybody? We're back with the last part of 9.5, and today we're going to be dealing with when we have vertexes outside of the circle. So we can have two secant lines, we can have one secant and one tangent, or we can have two tangent lines. So we have three different cases. And for this, I'm going to rewrite this. We can say that the measure of our angle, or the vertex of our angle, is equal to, we could say 1/2 times the big arc minus the little arc. I like to do the big arc minus the little arc divided by 2. And we have a shortcut, and it is only for this, and that is when it's like an ice cream cone. We have two tangent lines. It hits the circle one time for each line. Looks like an ice cream cone. Oh, my potatoes are ready. Oh, anyway, the measure of this angle right here is the measure of this arc. So this angle plus this little arc has to equal 180 degrees. Again, it is only for this when it looks like an ice cream cone. So, for number 1, I'll take a look at it. I have two secant lines because the secant lines hit right here and right here. So I'm going to say x equals the big arc, 120, minus the small arc, which is 50, divided by 2. And notice how the big arc and the small arc are in between this. So if I do some quick maths, x equals 120 minus 50 is 70 divided by 2. So x is 35 degrees. All right. So for number 2 is a little bit trickier. We can see that we have 120 degrees right here, 140. We know that a circle has to be 360 degrees. So if I add up this 140 and this 120, I get 260, which means I have 100 degrees left to play with. So this little arc is 100 degrees. So now I can do big arc minus a small arc. So x equals 120 minus 100 divided by 2. X equals 20 divided by 2. X equals 10 degrees. All right. For this one, we know that this is an ice cream cone shape because it hits one time here and here. Looks like an ice cream cone. Two tangent lines. We have 200 degrees that it gives us. So we know a circle is 360. So the remaining arc has to be 160 degrees. And our rule, well, I'll show you both ways. First thing is I can do, hey, big arc minus a small arc. So x equals 200 minus 160 divided by 2. X equals 40 over 2, and I get 20 degrees. Or we can do our little shortcut. We can say that this and this has to equal 180, so x equals 180 minus 160, and we still get 20 degrees. So either way is fine, but I'm just showing you might be a quicker shortcut for you. All right. What happens if we're given the angle? Well, just kind of like yesterday, we're still going to set it up the same way. We know that the angle, the vertex for angle 62 is equal to the big arc 141 minus our small arc x over 2. And I'm going to multiply both sides by 2 in order to get rid of that. So I get 124 equals 141 minus x. I'll subtract 141 from both sides, so I get negative 17 equals negative x, and then I got to divide both sides by negative 1. So 17 degrees is equal to x. And this one, so the last problem we just didn't have the small arc. Let's try something without the big arc. So I have 24 equals my big arc x minus my small arc 72 over 2. I'll multiply both sides by 2 in order to get rid of these 2's. So I have 48 is equal to x minus 72. I'll add 72 to both sides, and I get 120 degrees is equal to x. All right, so for this, you're going to have to use your shortcut method. We have an ice cream cone shape here. Hits 1, 2 times, so we know that this angle and this arc have to add up to 180. So let's say x equals 180 minus 53, and we just get 127 degrees. Not too shabby. Not too shabby at all. So for this one, you're also going to have to use your little ice cream cone trick. So we can do 180, because if I want to find this arc right here, we'll say, let's call that y. Y equals 180 minus 27, and we get 153 degrees. So 153, and I have the rest of this arc going around right here, and I know that a whole circle is 360, so I can say that x equals 360 minus 153, and for x, we get 207 degrees. And that's really it. We're going to have a quiz over all of 9.5, so that's going to be factoring when the vertex is inside the circle, as well as when the vertex is on the outside of a circle. So make sure you know all these cases. Please let me know if you guys got questions. TV recommendation that show I'm watching right now. It's on HBO, and actually HBO Go is a free subscription going on right now, so I recommend that. I'm watching this McDonald's documentary. It's called like McMillions or something like that. Basically, that whole monopoly McDonald's things in like the early 90s and 2000s, it was completely controlled by the mob. Super interesting. But yeah, let me know if you got questions. More than happy to help you out. Hope you guys are doing well.